Alright, so this is a new playlist, model editing, and it is, most of the articles in model editing is about NLP, maybe 80% of articles, but the rest of them is about computer vision, anything you imagine. And it is very important that it is also in harmony with neuroscience. So it's a very important recent researcher. It's very recent. Most of the articles are in the past 5 years. Memory-based model editing at scale. This important article, Christopher Manning in Stanford, Chelsea Finn, I think she's in Berkeley, and these the other relevant papers you see here that I will explain all of them in the future videos. So even the largest neural networks make errors, and once correct predictions can become invalid as the world changes. Model editors make local updates to the behavior of the base pre-trained models to inject updated knowledge or correct undesirable behaviors. Existing model editors have shown promise but also suffer from insufficient expressiveness. Same for the field of geometric deep learning that I really like. They suffer from expressiveness. So sometimes we develop something, but for example, in model editors, we have very big pre-trained models like ResNet, AlexNet in computer vision, like BERT in BioBERT, SciBERT in NLP. We cannot retrain them, but we can just fix. When your software has a bug, you just provide quick fix for that. You don't change all of your software just because of a simple bug. And the same motivation is here. And it is this area of model editing is more general than continual learning. Not more general, more you can quickly scale your model, because in continual learning you always have this. You want to minimize the weight and the weight of the last episode to force that it doesn't deviate too much, but you need to access all of them. But in model editing, you freeze your model most of the time. You freeze and you add an extra. So the addition that you add, it's an extra. So this is called post model, post edit, and this is called pre-edit model. So you can scale your model each time some addition, then you can scale it, and you just take care that the KL divergence from each step to the previous step is not too much. And so the idea of this paper is that as a higher capacity alternative, we propose semi-parametric editing with a retrieval augmented counterfactual model, which stores edits in the explicit memory and learns to reason. This is for 2022. This is 2022. Because many papers exactly are doing this. So it's a very important paper. To enable more rigorous evaluation of model editors, we introduced 3 challenging language model editing problems based on question answering, fact checking, dialogue generation. So you see that you have an edit model, and then this is the scope classifier that says that you should use it or not. So the classifier and counterfactual, the post-edit inputs are classified by whether the memory contains inputs relevant to processing them. If the classifier determines a relevant edit example exists, the input and edit example are passed to the counterfactual model. Otherwise, the input is simply passed to that base model, which is of course frozen. You don't need to worry about the weights. So large neural networks are typically deployed as static artifacts whose behavior is difficult to modify during deployment without retrain. But we have this fix. For example, this is the depiction of edit scope of edit descriptor who is the UK Prime Minister in a hypothetical semantic embedding space. So a hard in scope inputs lie. By the way, this is when they say hard words or hard samples. This is also another related topic. Even in active learning, you have hard examples because their uncertainty is too high. So you put it hard example, and there is another branch that I forgot the name of that. It's like active learning, but the idea is the same. Just for those simple, small number of hard examples, you don't need to retrain all of your pre-trained models. You just fix for these small number of hard examples. So the editing scope, so this is the edit descriptor, who is the sound public, and the input is the in scope input is the sound public license has been named for whom, and this is an out of scope input. So the wrap model is a semi-parametric model of this form f tilde. What is important is that in the forward pass, if it is less than a threshold, then you give your frozen base model. But it is more than that, which corresponds to those hard examples, you can have another H model. And training it is very easy. You just work on this. The scope classifier G is trained to solve binary classification problem where the input receives label 1 and the input Z out receives label 0, 0. The training objective for the scope classifier is the average binary cross entropy loss over the trained dataset. So you want to give it to classifier or not. The counterfactual model considers an edit and a corresponding example and is trained to minimize the negative log likelihood given your Z sub E and X in. And for question answering, the same idea. We define ES as simply average exact match agreement between the edited model and the true labels. So we have a pre-edit model, and then if you add that extra neurons to that, it becomes the post-edit model. So usually we try to reduce the KL divergence between pre-edit model predictions as post-edit. In model editing, we have some performance measures that I will explain in the future videos.